Welcome back to AT Math. Today, 1-5, square roots and real numbers. Well, a square root is a number that was multiplied by itself. It's kind of hard to explain, but the square root of 4 equals 2, meaning that 2 times 2 would make 4. So that's the idea. The idea is that you take a number and figure out what times itself would have made it. So in the case of 4, the answer square root of 4 is 2. Square root of 16 is 4, because 4 times 4 would make 16. So go ahead and give these a try. Did you get 5, 11, 7, and 15? Those are right. Also, on most calculators, you can also have a button for it. I'm not sure if it's on here. We'll take a look. This root button right here. So you could root. Let's go ahead and root the 4. You get the idea. So again, if you take 25, root that, you get 5, and so on and so forth. Now, much like before, when you have a negative and you have a square root, the root goes first. So the root of 4 is 2. The negative has to wait its turn and then becomes negative 2. The easiest way to remember to do the square root first, then add the negative after. Same here. Root of 49 is 7. Negative waits to make it negative 7. But the negative has to be on the outside of the square root. In other words, this is fine. This becomes negative 2. But this can't work. Why? Because no numbers multiplied by itself will make a negative. Now you might say, wait a minute, what about negative 2 times negative 2? But negative 2 times negative 2 would make positive 4. In fact, the only way to make a negative 4 would be a positive 2 or a negative 2. I mean, if you're using just 2's. And that's why it can't work. Negative has to be on the outside. This here is not possible. At least not for where we're at. Later in math, they have a thing for it, but for us, we'll just say the negative has to be on the outside. So go ahead and give these a try. Excuse me. Go ahead, pause. Let's see what you got. Right here, 625 makes 25, so it should be a negative. This here makes a 9, and a negative on the outside. This makes negative 6, and this is not possible. Defined, or whatever you want to call it. It makes no difference. Just not workable because of the square root of a negative. And that's not what we're trying to do right now. Now, not all square roots have a whole number answer. The square roots that did before are called perfect squares. The following will not be. For instance, the square root of 8. The question was, what times what makes 8? Well, you could say 4 and 2, 1 and 8. But if I said what same number times itself makes 8, that's a problem. What you would do is you use the root key in this calculator or others like it. If you root 8, you get 2.828 and basically what you would have is, it says, if I wanted to round to the nearest tenth, that's what I said, you round to the nearest tenth. So if this is the 10th column, it's the number after that decides it. So in other words, will become 2.8 or 2.9. The number after is a 2. If it was 5 or more, I'd round the 8 up to a 9. Since I don't, I just cut this off and it becomes 2.8. Simple. So you go ahead and try. I'll go ahead and pause and let you. Alright, hopefully you paused and seen. Let's go ahead and do these here. Take our calculator out. Let's go ahead and root 8. I get to the nearest tenth, again 2.8, because 2 doesn't round it up. Now I'm going to root a 5, 2.23 or 2.2. Let's go ahead and root 18. 4.2, the 4 will not make it go up, so just 4.2. And finally, square root of 12. 3.46, the 6 will promote it, so it becomes 3.5. Now let's apply this. If you have your book, page 33, example 2, it talks about a 19-foot garden. They want to know if you want a 19 square foot, how long to make each side. Why exactly would you want 19 square foot? I'm not so certain, but that's what they want. That means they want the length and width equal because they want a square. So x times x, whatever that x might be, has to equal 19. What you do is x squared equals 19 foot square, but don't worry about that square. Just think of x squared equals 19. Now I did something here I want to show you. So I have x squared equals 19. To get rid of this square and to find what the x is by itself, I simply root it. But like any other equation, if you do it to one side, you got to do it to the other. So I'm going to root this side too. So what you need to do is you need to root 19 and see what you get. So I'm going to go ahead and take 19 and root it. And I have 4.35. If I round it up, we'll say 4.4. So basically, if I made each side 4.4, I'd be pretty close to 19. If you notice, if I go ahead and take 4.4 squared times 4.4, notice that I get a little over 19, but I'm really close. So my estimates would be about 4.4 on each side. Would get me really close to 19. So yep, I root it. 4.35. The 5 rounds up the 3 to a 4, and there you have it. Also, you know, how do you know as well? Because if I go down to just 4 squared, that's 16. 5 squared is 25. 4 squared is 16, 5 squared is 25. 19 is in between these two numbers, so you know it's pretty good. And if you take 4.4 squared, you get 19.36. So that's pretty easy. Go ahead and you try, find the length and width for each one. This is 34, and a bit of a challenge one. This is 2.5. So go ahead and pause this time. Go ahead and write down your answers to the nearest tenth. Go ahead. Let's see how you did. Let's go ahead and take 34 and root it. I'm getting 5.8 on each side. I hope you got the same. And 2.5, just a matter of rooting it. Only 1.58, which is 1.6. Now, of course, for some vocab. I know, not always a favorite, but we need to do it. When they say the word natural numbers, that means positive numbers that are 1 and up. So 1, 2, 3, 4, 5. Whole numbers. Well, they're 1, 2, 3, 4, and 5, but they also include 0. So whole numbers are natural numbers, but include 0. Natural numbers were just 1, 2, 3, and up. Whole numbers, by the way. In other words, you can't have a decimal. Integers are whole numbers that include negatives. So here you can have 1, 2, 3, 4, or 0, or -1, -2, -3, but no decimals. Rational numbers are integers including fractions and perfect squares. So they include those guys too. So you have fractions, perfect squares, and that would also mean decimals of certain types. But when they break down decimals, there are two types of decimal. Terminating decimals are decimals that stop, like 2.5 and that's it. Or 3.456 and that's it. They don't keep going. Or you have repeating decimals, decimals that keep going but in a certain pattern. 1.33333333, 3.67676767, and here 2.11111111. Now those are all all these are under the tent of rational numbers. So I should explain that rational numbers include all these and all these. The other type are irrational numbers, and irrational numbers are simply decimals that keep going but don't repeat. Like 2.345985887. You don't know what the next number is going to be. Also, irrational numbers are square roots that are not perfect squares, because if you rooted 2, as we can do right here, notice that this also goes into a pattern, excuse me, not a pattern, but it goes on forever without being in a pattern. So that's how you know. So all these are rational, as you can see here. And irrational is just irrational numbers, nothing other than that. Which were these square roots that aren't perfect squares and decimals that keep going but don't repeat. Everything else is under the tent of rational numbers. So you try. First of all, tell whether they're rational or irrational, and if they are rational, what type. Take a look here. Feel free to flip back through the video to see here. But basically, everything except irrational numbers is going to be rational. So go ahead and give it a try. Tell whether they're rational or irrational, and if they are rational, what type. Go ahead and pause. Let's see how you did. This is rational, and this is a terminating decimal. This is rational, and this is a repeating decimal. Now, here, I would accept a couple things. Clearly, it's rational. Now, if you wanted to say simply it's a rational, that's fine. If you want to say it equals 3, if you want to say it equals 3, then it could be a natural number. You could say it's a whole number. You could say it's an integer. So what's most precise? Well, if I was talking to a guy in my class named Johnny, I could go up to him and say Johnny, or I could say, hey fella, or I could say hey human. But clearly the most common, or best reference, not most common, the best reference, we call him by his name. In that same way, the most precise way to say 3 would be using natural numbers, because that's the most exact. Even though 3 is a whole number and an integer, 3 is most specifically a natural number. 8, again, is a natural number. So both of these truly are natural numbers. But if you said this was just a rational number based on the square root, I'd accept that. 1/2 is a rational number. 2.4356, blah, 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 not really a pattern. So that is an irrational. -5 is an integer. Why integer? Because it's a negative. Whole number, yes, but integer. It would be a whole number, but it's negative, so it's an integer. And 3.565656 is a repeating decimal, as it does repeat over and over and over. We'll hold off on this till the morning. I will have a quiz for you. Thanks again. Until next time.